Am I audible to everyone?
Yes,
Are you
sir.
getting my voice? Okay, okay, okay. So I'm just going to share the screen that will allow to. Okay. Now, hopefully you are able to see the screen. So in yesterday lecture, we have discussed about law of conservation of energy, and I think about the charges, what are the charges, and how we are classify the charges, voltages, concept of voltages, or you can say that the concept of electric potential. From this session, we are going to discuss about the different type of concept related to the basic concept related to the circuit theory, as well as these are concepts also used in the power system machine, and all these things, like when we are going to calculate the efficiency, then you have to calculate the power, you have to calculate the heat, you have to calculate the regulation. So all this basic concept will most rapidly used in other subjects also. So we are going to start with one most basic thing, which is known as the current. What is current? So one thing, I'm just uh, your paper will start, I think it is near about 4th of April. April. 4th to 6th April. 6th April. So please make your mind in such a way that your classes will be most probably the minimum class hour should be 3 hours, and maximum it should be 6 hours. It should be 6 hours. In this manner, if we are going to cover this way, then we can cover all your syllabus. Just like you can say that in your control system, it is a vast syllabus. Also, machine have a large, you have to study the machine, which is start with the transformer, DC machine, synchronous machine, induction machine, then single phase. So we have to cover all this segment. So we have to attend at least 4 to 5 hours class of daily class. So please make your mind, minimum hour of class should be 3 hours, and maximum it should be 6 hours daily. Okay. Uh, in If we are going to study in such way, then we are able to cover up to, I think, 30 of March. 30th of March we can cover. So please make your mind in such a way that you have to study at least 3 hours per day, and at most 6 hours. Now, anyone please define the current? Anyone please define the current? How can you define the current? How can you define the current? Sir, this one is current. We can define the current in this way. How can you define the current? Basically, current is a rate change of charge. Current is a rate change of rate of flow of charge. It is defined as the rate of flow of charge. The rate of flow of charge is known as current. So we can say that I is equals to, this is a rate of flow, and this one is your charge. This one is your charge. So you can say that, just a minute, just a minute, just a minute. Just a minute. You can say that I is equals to a rate of flow of charge. Now, how can you determine the unit? How can you determine the unit of current? So current is equals to rate of flow of charge. Rate of flow of charge means, sir, dq by dt. A small charge moving with a constant velocity, that is dt, with respect to time. The unit of charge is coulomb, and the unit of time is second. So you can say that current is unit is coulomb per second, or you can say that ampere, or you can say ampere. Ampere is the unit of current. Now, in similar manner, if we are going to deal the current, that is charge, total charge upon time taken, total time taken, total time taken, how much time it will take. That is, you can say that q is equals to t. So now, if I'm going to ask the value of q, you can say that, sir, it is a simple multiplication of I into t, I into t. And we know that the unit of this charge, this is also a formula, or you can say that method to determine the charge, if you have the current flowing through this, through any conductor for a definite period of time. Now you can say that, sir, the unit become how much it become. Unit of charge is coulomb, or you can say that ampere per second. So ampere per second is also the unit of charge. Coulomb is also the unit of charge. So unit of charge is simply coulomb or ampere per second. So this is the basic fundamental unit, which is called the current. Now the another fundamental unit, that is energy. Energy. How can you determine the energy? Anyone? How can you determine the energy? Anyone? How can you determine the energy? Please, please. How can you define the energy? The rate of flow of charge, capacity of doing work. Very good, very good, very good. Power into time. Very good, very good. Uh, actually, only two people are responding, and that is not a proper way of studying. Either you are studying in your so try to respond. Either it is wrong or right, doesn't matter. First of all, you have to show your determination. It will determine, it will also uh, determine that how much I have to work on you, how much you people are aware of this topic. So don't judge by typing or by responding the answer. Don't judge anything that, oh, I don't know that it is a simple. Don't think like that. Just simply reply the answer. So what is energy? It is a capacity. It is a capacity, or or the the ability to to do the work, do the work and its unit is, anyone, please respond. Unit is okay. Let me if I have to determine the unit, then I know that is the rate of change of energy is known as power. Rate of change of energy is known as power. Very good, joule. Now what if I'm going to tell you that, so simply you can multiply this fractional part with this value and integrate with both side with a definite time period, then it become the energy or you can say that energy. This is work done. Work done is also known as energy. For a definite if a work is done for a definite period, then it become energy. Energy is equals to 0 to t p of dt. Now the unit become, you can simply say that, sir, it is very simple. The unit become, and the unit become energy. Sir, power into time. Sir, energy is equals to p is equals to power is measured in watts. Power is measured in watts. So unit energy is equals to p into t. P into t, that is watt watt per watt into second, or you can say that energy, unit of energy is joule. Joule is also the unit of energy. Now these are the basic concept, basic terminologies related to the electric circuit. Now we are going to discuss in the circuit theory, that is the circuit element. Important properties are the circuit element. Circuit elements. We are going to discuss the circuit elements. What are the circuit elements? Just we are going to discuss the resistor, inductor, capacitor. Basically, we are going to discuss all these elements. But my style of teaching is something different. That will totally differ from the from others. Just like to determine the resistor in a separate manner and determine the capacitor in a separate manner, inductor with a other separate manner. No. I'm just going to tell you about Ohm's law. Ohm's law. And this law will determine every element in a specific manner that will allow to know you that what are the resistor, what are the inductor, and what are the capacitor. Definitely. So please be attentive. Attentive. I'm going to start the Ohm's law in such a way that will determine or extract the elements like resistor, inductor, and capacitor. So, anyone, please tell me about Ohm's law. How many of you are most burning topic? How many of you are most aware with this topic? V is equals to IR. Okay. I'm just okay. Uh, let me. This is a simple way to explain the V is equals to IR or V is equals to RI. Anyone, please define the Ohm's law. Please define the Ohm's law. Please define the Ohm's law. Anyone, please define the Ohm's law. Okay, let me. I will tell you 8 types of Ohm's law. Hmm. Current is directly proportional to voltage and inversely proportional to resistance. Inversely proportional to resistance. No. Okay, let me. First of all, it states that just it states that at constant temperature, temperature, pressure, humidity, etc. At constant temperature, pressure, humidity, etc. Means the physical condition, the physical, the physical condition, etc. It states that at this is constant temperature, pressure, humidity, etc. The physical condition, while having the physical condition, the current density, please mind that the current density the current density is proportional to is proportional to electric field. Electric field. Current density is proportional to electric field intensity. Intensity. Now, what is this? What this tries to explain? This tries to explain like this. Let us suppose you have a conductor. Please be attentive. Please be attentive. First time you are going to learn this Ohm's law in that manner, in that detailed manner. I can bet on, but I can bet most of the student are not able to know that exact. This is the exact Ohm's law. Exact Ohm's law. This is exact Ohm's law. Please be attentive. Be attentive. Because in this topic, are going to deal many concept. Many concept. Suppose this is a conductor and conductor have many free electrons. Free electrons means loosely bounded electrons. The outermost electron present in the atom is this. These are the loosely bounded electrons. Are you getting my point? These are the loosely bounded electrons. If this is any voltage, these are the two voltage terminal that is determined by different polarities. This one is positive and this one is negative. So if you have different polarities, then there is an electric field from positive to negative. Positive to negative. Let us suppose this voltage is variable. Let us suppose this voltage is variable. If we are going to change this value of V, then electric field get varies. Are you getting my point? Till now, are you getting my point? Till now, are you getting my point? Is there any issue? Any issue related to any concept? This is simply conductor. Conductor. If we are going to increase the voltage, this will increase the electric field. This will increase the electric field because the charge accumulation, these are the positive charge and these are the negative charge. The charge accumulation are different. This will create a electric field difference. This will create a electric field difference. So if these are the electric field difference, then electric field, if we are going to increase the voltage, electric field increases. Are you getting my point? Till now. Till now. Please reply. Are you getting my points? Are you getting my points? Sir, if we are going to increase the voltage, electric field is also increases. Electric field is also increases. Electric field is also increases. Okay. Okay. Now, what I'm saying that, sir, there are two concepts. First of all, current density. Current density. Current density is denoted by J. It means the current flowing per unit area. How much current will flow? Let us suppose that in this conductor, this is the cross-sectional area of this conductor and current flowing through this cross-sectional area. Current flowing through this cross-sectional area is A. Any current, let's say this is current I. So current flowing through this cross-sectional area is given by current density J. This is given by current density J. And let us suppose this is the length of the conductor. This is the length of the conductor L. Length of the conductor. Now what? I'm saying that the current density J is directly proportional to the electric field. Why I'm saying that? If we are going to increase the electric field, in yesterday's session, I have told you that I had told you that if there is an electric field, if there is an electric field, any negative charge is placed in electric field, then the force experience on the electric field is opposite to the direction of electric field. This is the force of attraction. Due to this, if the direction of electric field is from left to right, then the force experience on this negative charge is become right to left. Due to this force experience, the free electrons present on this conductor is try to drift towards this manner due to this drifting velocity. Due to this drifting velocity. Is it clear? Is it clear? Is it clear to everyone? Due to this electric field which is applied on the conductor from one end to the another end, there is a drifting velocity on the free electrons or loosely bounded electrons. Yes, sir. This is this is already discussed. If we are going to remove the proportionality constant, this become replaced by a constant value, that is sigma E. This become replaced by the sigma E, where sigma is equals to, sigma is nothing but, that is conductivity. Conductivity means how much, how many electrons are eager to flow the small value of electric field from this end to this end, or how much electrons are easily liberated when electric field applied on the conductor. This is determined by the sigma. This is known as first form of Ohm's law. This is known as first form of Ohm's law. This is called first form of Ohm's law. Be simple, be perfect. Actually, this is the Ohm's law. This is known as first form of Ohm's law. Ohm's law. First form of Ohm's law. Or this is also known as microscopic form of Ohm's law. Microscopic scopic form of Ohm's law. This is also known as microscopic first form, or one another name is uh, microscopic first form, and the another name is point form of Ohm's law. Ohm's law. So this is the first form of Ohm's law. Now we are going to remove this value. J is replaced by IA. J is replaced by IA. IA sigma E. And we know that what? We know that where where rho is equals to 1 by sigma, or you can say that sigma is equals to 1 by rho. It is clear? Sigma is equals to 1 by rho. And another thing, electric field is defined by how much voltage you are going to apply electric field E upon me, how much voltage you are going to apply V upon me L. That is applied voltage upon me length of the conductor. We are simply replace this value. I by A is equals to 1 by rho V by L. V by L. Now this expression become look like this. This expression become look like this. That is I by A is equals to 1 by rho or V by L. This will look like I rho L is equals to V into A. V into A. Or we can say that V is equals to just rho L by A into V. So rho is equals to resistivity. Rho is equals to resistivity. Resistivity of material. Material. A is equals to cross sectional. Cross sectional. Cross sectional area. Area of conductor. Conductor. L is equals to is length of conductor. Conductor. So a rho resistivity is a constant value. Cross section area, if we have determined the conductor, the length cannot be changed, cross section area cannot be changed. This is also the constant value. So A is constant, L is constant, resistivity is constant. So we can say that this expression become V is equals to, oh my god, V rho, I think V is equals to rho L by A into I हो जाए. Now V is equals to RI. This is the second form of Ohm's law. This is the second form of Ohm's law. Second form of Ohm's law. Ohm's law. Are you getting my point? This is the second form of Ohm's law. Where R is equals to rho L by A. R is equals to rho L by A. This element become resistor. R is equals to a resistor. Resistor element. So I told you that circuit element. Our first element is a resistor. Our first element is a resistor. Are you getting my points? Are you getting my point? हाँ. हाँ, वही शिफ्ट वाला पेपर डाल दीजिएगा. हाँ, जो भी आज मंटू पेपर करवाएंगे वही डाल दीजिएगा. ओके. सो सो this is the second form of Ohm's law. This is the second form of Ohm's law. Now, what it states? It states that it states that it states that it states that temperature. What is this? It states. It states that voltage is voltage across the element is directly proportional to the directly proportional to the current provided the physical condition remain same such as temperature, pressure, humidity, etc. This will remain constant. If all these parameters remain constant, then voltage is directly proportional to the current. Voltage is directly proportional to the current. Now, the another form. Okay, if we are going to talk about the resistors, then we have the parameter. Sometimes they have asked on which parameter the resistors are depends. On which parameter the resistors are depend. So parameters related to the resistors. Parameters. Parameters related to resistors. Parameter related to resistors. So first of all, a resistor varies with the temperature. Resistor varies with temperature change. temperature change. As the temperature changes, the value of resistor changes its value. That is R is equals to R naught 1 plus alpha delta T. Alpha delta T. If alpha is equals to temperature coefficient. Temperature coefficient. Delta T means T2 minus T1 is a temperature change. R naught means resistance resistance at 0 degree Kelvin. Degree Kelvin. So these are the values. As alpha changes, the value of resistance will changes its value. Alpha for metal, note this is very important point. They have asked that. Note, note. The point is if alpha is positive temperature coefficient. Alpha is positive temperature coefficient efficient for metal, and alpha become negative temperature coefficient, negative temperature coefficient efficient for semiconductor semiconductor. Now, what they have told for semiconductor the alpha become negative, or for metal they have positive. So for semiconductor, semiconductor means those material which have both the property. R of T is equals to R naught 1 minus alpha delta T. If we are going to increase the temperature, then resistance become decreases. If you are going to increase the temperature, the resistance become decreases. If you are going to increase the temperature in metals, then resistance become increases its value. So these are the properties of a resistor and semiconductor, and we have defined two form of Ohm's law. Now we can also rewrite the we can also say that the first parameter, resistor, varies with the temperature. Also the second parameter, if resistor changes its value if the dimension of material changes, if the dimension of material is changes, as we know that R is equals to rho L by A. It means resistance is directly proportional to the length, and resistance is inversely proportional to the cross section area. If we are going to increase the value, increase the area, then resistance become decreases. If we are going to increase the length, resistance become increases its value. So resistance is directly proportional to the cross section, directly proportional to the length, and inversely proportional to the cross section area. Very, very important. They have asked a lot of questions related to this concept. Very much a lot of question related to this concept. So if they have asked that if the length increases, if the area increases, what happened to the value of the resistance? So they have asked the question related to the proportionality. How can you are going to handle for change of length and area. If they are going to ask such type of question, the length is changed by 2 times, the length is changed by 3, area is changed by 3 times, what is the effect, what are the effect on the resistance? Then you can simply say that R2 upon में R1 is equals to L2 upon में L2 upon में L1 into A1 upon में A2. Simply from this relation you can easily determine the change of resistance. Actually this one is R1, this one is R1, this one is R1. Such type of question they have asked, related to this concept, just like simply they have asked if the value of if the value of resistance is 2 ohm 2 ohm 2 ohm and length is increased by and length of a resistor increased by 2 times where area get decreased by 4 times the new value of resistance. Determine the new value of resistance. Determine the new value of resistance. New value of resistance. Determine the new value of resistance. Nothing to worry. The value of resistance R is equals to 2 ohm. Let's say this one is R1. Now you have to determine R2 if here given that let L length become L1 and cross section area become A1. Cross section area become A1. If length changes, L become L2 times and L2 become how much time? 2 times increases. So let's say the initial value is L1, then it become L2 and cross section area A2 decrease by 4 times. It means if this one is A and it is decreased by 4 times. Now you have to apply the formula simply, that is L1 by L2 into A2 by A1. That is length L1 become L1, length is L1 and L2 become 2 times of L1, 2 times of L1. Cross section area A2 become A1 by 4 times and what? A1 become A1. This one is A1. Now you can replace this value, that is L1 by 2 L1 into A1 by 4 A1. A1 get cancelled. L1 get cancelled. R2 by R1, the ratio become 1 by 8. So R2 is equals to R1 eighth, 1 by 8 time of R1. So the value of R1 is 2 2 by 8, that is 1 by 4, that is equals to 0.25 ohm. Such type of simple question they have asked, the value of resistance you have to determine. Is it clear? Is it clear? Now, sometime they have asked the specific resistance. They have asked what is specific resistance. Note, they have asked what is specific resistance. What is specific resistance? What is specific resistance? So basically, specific resistance is nothing in the place of rho L by A. If length become 1 meter and cross section area become 1 meter square, the resistance become resistivity. The resistance become resistivity 1 by 1, that is equals to rho. This is known as resistance. ये आपके पास this become resistivity. So if area cross section area of conductor is 1 meter square and length of the conductor become 1 meter, then it become resistivity. It become the specific resistance. So hopefully you are getting my point. These are the terms related to the resistance, the parameter on which resistance depend. We have discussed till now to second form of Ohm's law. Now moving forward, just a minute. नमस्कार सर, क्लास ही ले रहा था सर. हाँ, अरे मेघालय वाले. हाँ हाँ, मार्च अप्रैल में पेपर है ना। अप्रैल में 4 तारीख को पेपर है इन लोग का। ठीक से ठीक ठीक। सही है ना, कोई इशू तो नहीं है ना। Okay, so these are the terms related to the resistor. Now, uh, we are moving forward from second form of Ohm's law. We have another, we can also rewrite this Ohm's law in different way. V is equals to Ri. This can also written as V is equals to I is equals to V by R. Or you can say that, sir, I can written like this 1 by R into V, that is I is equals to G into V, where G is equals to 1 by R is known as conductance. Is known as conductance. Okay, tell me about the unit of resistance. Tell me about the unit of resistance. Unit. Unit of resistance. Unit of resistance. Anyone? Unit of resistance. Sir, R is equals to V by I, that is volt per ampere. Also one thing, it is denoted by ohm, and the symbol is this, ohm. Symbol is ohm. Okay. Now, so the unit of conductance, sir, the unit of conductance is given by, you can rewrite this expression. Sir, R is given by V upon may I. This will get reverse. I upon may V. It means current, and this one is voltage. So current per volt, or this is mho. This is given by this. Or you can say that Siemens. Siemens. Siemens is also the unit of conductance. It is just a reverse case of, just reciprocal case of resistance. Conductance is the, and this form of law, and this form is known as what? This form is known as third form of Ohm's law. Ohm's law. You can say that, sir, if resistance is constant, if resistance is constant, if resistance is constant, if resistance is constant, then G is equals to 1 by R, that is equals to 1 by constant value, then it become Z should be constant, conductance should be constant, so current is directly proportional to voltage also. Current is also proportional to the voltage. The same parameter, the same value, provided provided physical condition physical condition should remain same. Physical conditions should remain same, such as temperature, pressure, etc. Now, the another form is also rewrite in this term, that is V is equals to Ri. From this, we can rewrite this dq by dt. This is the fourth form of Ohm's law. Just mark my words. This is the fourth form of Ohm's law. Ohm's law. This is the fourth form of Ohm's law. Are you getting my point? I just replace the value of current with the specific value, that is dq by dt. dq by dt. One question is most probably they have asked in interview questions. In interviews, they have asked why, while defining the Ohm's law, while defining the Ohm's law, Ohm's law, why you why the physical condition such as such as temperature, pressure should be constant. Anyone? In every Ohm's law, while defining the Ohm's law, we have told you, I, I have told you that the physical conditions should be remain constant. Why? The physical conditions should remain constant. Why? Why I have asked while defining that definition, I have always told you that the physical conditions should remain constant. Physical conditions should remain constant. Why? Is there any specific uh, parameter that will get disturbed, or why I have told you, sir, always physical condition should be remain constant. Physical condition should be remain constant. Is there any specific reason behind this? Any specific reason behind this? Any specific reason behind this? Actually, let me tell. Actually, if you are going to change the temperature, if physical condition will not remain constant, then temperature will get changes. If temperature changes, then resistance changes. And if the value of resistance changes, then voltage is directly proportional to current is not a validated definition. If voltage is directly proportional to current or current is directly proportional to voltage, it means to validate this definition, you have to be sure that resistance should be constant, and for constant resistance value the temperature should be constant. Are you getting my point? If resistance get varies, if resistance get varies, then is voltage does not directly proportional to the current. So for constant value of resistance, you have to take a physical conditions should be constant. Are you getting my point? Most of the time interviewer have asked this one, why the physical condition should remain constant. It is just because for the proportionality constant between the relation between the voltage and current. Are you getting my point? Are you getting my point? Are you getting my point? Hopefully you are getting my point. No. The another relation, the another relation, another relation. Basically, we have developed the relation between voltage and current from in Ohm's law. If this is related with the voltage and current, rate change of charge, this relation is also between the voltage and current. This relation is also between the voltage and current. Ohm's law basically related with the voltage and current. So next relation is also related with the voltage and current. Next relation is also related with the voltage and current. That is, let us suppose that let us suppose that hmm, a current carrying wire, a current carrying wire, which is folded like this, which is rolled like this. If a current flowing through this conductor, then a flux get induced through their surrounding. That is flux phi. Flux phi. So the induced voltage V is equals to given by N d phi by dt, where N is equals to number of turns, where N is equals to number of turns. N is equals to number of turns. The induced voltage V is equals to N phi by d, N uh, N into d phi by dt, where flux phi is directly proportional to current. The flux induced in this conductor is directly proportional to the current. Now we can say that this psi is equals to n phi, number of turns and current. A specific function psi is determined by n into number of turns into flux in the conductor. So you can replace this value. You can replace this value if the proportionality constant is eliminated, that is Li, where L is equals to inductance. Where L is equals to inductance. Where L is equals to inductance. L is equals to inductance. Let's say this is expression number 1. Let's say this one is expression number 1 and this one is expression number 2. This is expression number 2. Now, voltage is also determined by if a current flowing through this conductor, that is I, and you have to calculate this value. So V is given by L di by dt. L di by dt. Let's say this expression is third. This expression is third expression. Now it states that what it states, inductor is if you are going to compare this expression or this expression, this expression and this expression. So from first and second expression, you can simply say that inductance L into I is equals to N phi. So you can say that, sir, simply inductance L is equals to N phi upon may I. N phi upon may I. That is the another element known as inductor. That is the another element known as inductor. Inductor is measured in Henry. It is measured in Henry. It is measured in Henry. So basically, this is the inductor which is measured in Henry. Now, one another thing, that is inductance is also written like this. That is the permeability mu into A into mu. Mu means permeability, N square upon may L. N square upon may L into cross section area. This is also referred the inductance, and this the value of inductance is written like this, N phi upon may I, that is inductor. This is the fifth form of Ohm's law. This is the fifth form of Ohm's law. So this is the value of inductor. Inductor is defined like this, where N is equals to number of turns. A is equals to section area. L is equals to length of wire. Again, the relation of voltage and current is developed in here also. The relation between voltage and conductor is also developed here also. So this is also a Ohm's law. Another form. Another is capacitor. Another is, you can also rewrite this equation like this. If V of L is equals to L di by dt, you can rewrite this expression like this. Sir, di is equals to 1 by L integral of 0 to any time t, V of L into dt. You can say that current through the inductor is given by IL 0 to t VL by dt. This is the another relation between the current and voltage. And if there is any relation, then it becomes the I think this one is sixth form, fifth form. This becomes the sixth form of Ohm's law. Ohm's law. Now we are moving further uh, towards the seventh form of Ohm's law, or any value. So we can say that uh, before moving towards the seventh and eighth form of Ohm's law, first of all, I would like to introduce the behavior of inductor. Please remember this words, uh, this concept, because when we are going to study the uh, transient analysis, this concept is very, very, very much important. So inductor, VL is equals to L di by dt. If VL is equals to L means inductor, what if d of t means very small? D of t means very small. If the current is given like that, this is current dt tends to 0. Let us suppose dt tends to 0. Then VL should be infinite. VL should be infinite means open circuit. It become open circuit. So it states that if the time is tiny, very small, then the inductor become open circuit. If the time is very small, then inductor become short, inductor become open circuited. It means what? Inductor behave like a open circuit for AC source. Inductor behave like a open circuit for AC source. For AC source, this inductor behave like a open circuit, and similarly for DC source, inductor behave like a short circuited for DC source. For DC source. For DC source, inductor becomes short circuit. For AC source, inductor become open circuit. Please remember this concept while we are discussing the transient analysis, which is mentioned in your syllabus. We are moving forward towards the capacitor, and this is the seventh form of Ohm's law. Let us suppose a capacitor. Before describing the capacitor, one most important thing, that is inductor. Energy is stored by the inductor. How much energy is stored by the inductor? Very important topic. Energy is stored by inductor. An inductor stores the energy E is equals to half Li square. You can also replace this value. Acha, one most important thing. Energy is stored in the form of energy is stored in form of magnetic field. Energy is stored in the form of magnetic field. Important point is that if we are going to replace this value, A is equals to half L I square. Replace this I with this L with psi. You know that L is equals to N psi upon I. You can replace this value with L. L is equals to N psi upon I. that is I square. I get cancelled to each other. That is 1 by 2 and psi I. This is also the formula related to the energy. Energy. Uh, you can also rewrite this value in terms of energy. If you have only current and uh, current, flux, and number of turns. This is also the formula, if the formula where you can determine the energy, where you can determine the energy. Now, this is also the formula, or you can rewrite this expression E is equals to how much? E is equals to 1 by 2 psi I. Psi I. This is also the formula. Also one another formula. Need not to learn all this. You can you should have known each variability, so that you can eliminate the option, or you can find your most appropriate answer related to this form, related to this value. Now, you have told, you known that, that is I L is equals to L is equals to n phi upon me I, or you can say that L is equals to psi upon me I. So you can say that, sir, I is nothing but L into I is nothing but L upon psi. So you can also replace this value by psi into the value of current L and psi. Value of current L and psi. I think is it psi square upon L I, sorry, this will be the expression psi upon me L. So this will equals to psi by L, that is half psi square by L. This will the expression of energy. This will the expression of energy in inductor. Please note down many times this question this question had asked. Okay, the last but not least, that is capacitor. This is inductor, and the another one is capacitor. You can determine the capacitance by this. This is parallel plate capacitor. Two conductors, two parallel plate. These are the parallel plate. Parallel plate. Parallel plates have generally stored the charges. They have stored the charges, due to which they develop the electric field. They develop the electric field. Now, it states that the current through this charge is given by dc dv by dt, or you can say that C is equals to capacitance. C is equals to capacitance, or you can rewrite the charge Q is equals to CV. Q is equals to CV. Q means the charge is stored by this parallel plate, that is given by Q. Q is equals to CV. If you are going to differentiate both the side, you can differentiate like this, that is CV. Now this one is I is equals to C dV by dt. That is the also the expression of current flowing through the capacitor. So current is directly proportional to rate change of voltage. If such expression is also developed between current and voltage, then it will also become the Ohm's law, and this will become the seventh form of Ohm's law. Seventh form of Ohm's law. Or you can rewrite this expression V of t is equals to 1 by C 0 to t, that is I of t into dt. This become also the expression related to the Ohm's law, and this become the eighth form of Ohm's law, because here also voltage and current are related to each other. When there is any relation between the voltage and current, it become specified as a Ohm's law. This become the seventh form, and this become the eighth form of Ohm's law. Ohm's law. This become the eighth form of Ohm's law. Are you getting my points? Are you getting my word? Are you getting my points? So these are the these are the brief introduction, brief, or you can say the detailed introduction of Ohm's law as well as the element behavior. Element behavior. Element behavior. So if you are go through if you are going to revise all this in 2-3 times in a day, then you can easily learn all the Ohm's law. You have simple relations. You have to determine, just replace the value with one another. You can get easily you are able to determine all the values. Now, the another relation, energy is stored by the capacitor. Energy is stored by the capacitor. Energy is stored by capacitor. How much energy is stored by the capacitor? Anyone? How much energy is stored by the capacitor? Anyone? Anyone? How much energy gets stored by the capacitor? Energy is stored by the capacitor. Please reply. How much energy gets stored by the capacitor? Half CV square. Very good. So energy is stored by the capacitor. That is equals to, energy is stored by the capacitor half CV square. Energy is energy is stored by the capacitor in in the form of electric field. In the form of electric field. You can easily say that in the form of electric field, you can store the energy. Okay. Now, if you are going to replace this value, half, in place of C, you can say that QV. Sorry, in place of C, we know that Q is equals to CV. So you can say that C is equals to Q by V. So in place of C, you can replace this value C with Q by V, then into V. V get cancelled to each other. Energy is equals to half QV. This is also the expression of energy. This is also the expression of energy. This is also the expression of energy. Now, energy is stored. Energy can have this formula also. Now, if energy is given by this, you can rewrite this expression. V is equals to Q by C. You can replace this V with this value, that is Q by C. So you can also rewrite the formula of energy, that is Q square by C. This is also the expression of energy. This is also the expression of energy. So be simple. Don't get too much load about this formula. You can always replace this value with, if you are very known to this formula, so you can easily, you are able to easily identify this formula. Need not to worry that you have to learn all the concept or all the formula. Just simply you can replace this value C and the value of V. The another thing, capacitor does not allow, just like this. Capacitor, just like inductor, capacitor does not allow, if the small time changes, then inductor voltage become infinite. In a similar manner, I is equals to C dV by dt. If dt is very small, tends to 0, then current become infinite. It means if current become infinite, then it become circuit. Short circuit. It means capacitor, capacitor does not doesn't allow the sudden change in the sudden change of voltage. It does not allow the sudden change of voltage, similar to the inductor doesn't allow the inductor, if the time change is very small, then inductor become open circuit, or you can say that inductor doesn't allow the sudden change of current current in a similar manner. Yeah, I just rewrite this. Inductor doesn't allow the sudden change of current, but capacitor doesn't allow the sudden change of voltage, because time period is very small, then it become infinite means short circuited. Another point, for capacitor behave like behave like short circuit for AC source AC source, and capacitor behave like behave like open circuit for DC source. It behave like open circuit for the DC source. So all this, these are the relation between current and voltage. These are the relation between uh, capacitor, inductor, as well as a resistor related to the Ohm's law. So hopefully, if there is any doubt, you can simply ask, sir, in this concept there is an doubt. There is an doubt. No problem. No problem, no issue at all. Just you can simply ask, sir, I have doubt in this topic. No need to worry that what if I don't know, I have no idea about this. Need not to worry anything. Just you can simply ask. Now, we have completed the circuit elements related to Ohm's law. Ohm's law. The another thing is Kirchhoff law, KC, that is KVL and KCL. So our next topic is KVL and KCL. Till now we have completed our circuit element. Uh, this is the Kirchhoff law, and we have also completed the different parameters. There is any parameter, transient response, steady state, mesh and node density. So today we are going to cover this one and this one. Simply these two topics. And if time allows me, then I will take the network theorem also. I will take the network theorem also and its application. Hopefully, we are going to study till 6th of PM, 6 or 7 PM. After having some break, don't get that much. So, we are going to deal with the next topic, that is KVL and KCL. Are you fine? Fine. Are you? Don't take too much stress that we have started at 3 p.m. and we are going to study at 6 p.m. or 7 p.m. Oh my God, that is too hectic. Okay. Now, our next topic is Kirchhoff It is also mentioned that Kirchhoff current law, Kirchhoff voltage law. So basically, in short form, they are known as KCL, Kirchhoff current law. This is also known as first form of first form of Kirchhoff. Kirchhoff, first form of Kirchhoff. Maybe there is a spelling mistake. Uh, don't take it too much serious. There is a spelling mistake. I think I'm missing like KIRRCHOFF. I think this one is, yeah, no, KIR Kirchhoff. Okay, okay. We will take it later. Now, first of all, we are going to study the KCL. KCL states that the algebraic summation of current at junction point at junction point should be zero. Zero. Important thing is that what is, sir, what, I don't have that much idea. It is the summation. Summation means addition. Okay. Addition of current. Where they are going to add? At the junction point. Where they are going to add? At the junction point. Junction point means the node. Junction point means the node. The addition of algebraic addition of current at the junction point should be zero. It means, let's say, sir, this one is a junction point. Junction point is defined as the point where two or more paths, the point which have more than two paths, it become the junction or node. Let's say this is current I, this is current I2, I1, I2, I3, and this one is current I4. So if you are going to deal with this, that is, this is become the junction point. This has become the junction point. Now, they are saying that the summation of current at the junction point that become the zero. It means, sir, the summation of current I1, I2, I3 and I4 at the junction point, it becomes zero. Are you getting my point? Are you getting the definition? Sir, junction means this value. Are getting, sir, junction is the point where more than two paths are allowed, then the point that node become the junction. This is also known as node. This is also known as node. This is also known as node. Now, this while determining the junction, first of all, I would like to introduce the word junction. Junction junction the common point which have have more than more than two path they become the junction. And sometimes they are also known as node means the common point. Node means the common point where more than two elements are get connected get connected get connected. For example, let us suppose this is resistor and this one is inductor. This is also a node. This is also a node, but this is this is not a principal node. This is simple node. Simple node. This is simple node. This one is resistor, this one is inductor. But I have take the example where more than two elements are connected. More than two elements are connected. Let's say this one is resistor, this one is inductor. In between resistor and inductor, there is a node. This is the node. But this becomes the simple node. But if there is an inductor is and capacitor is also connected, let's say R, L, and C, this one it become principal node. Principal node. Because the path of current here, if you flow, if there is a current I, then the same current will flow through the inductor. But in this case, there is a provision to flow the current I1, I2, and I3. If current get divides with at any point of any contact point or any common point get divided or added, then the node become the principal node. Are you getting my point? The basic difference between simple node and principal node, and what is node and what is junction. Junction is simply the point, the common point where more than two paths are available, then it becomes junction. And node where two or more elements are get connected, then it become node. Are you getting? Are you getting my point? Are you getting my point? Are you getting my point? Sir, simply junction become the point where two or more paths are available. More than two paths are available, then it becomes junction. And the same junction point become the node. Node are basically two types, simple node and principal node, where the current get divide node. If current get divide, if current get distributed or divides, then it become then node become the principal node. Then node is principal node. Either it become simple node. If current doesn't divide, then it become a simple node. Are you getting my point? Are you getting my point? What is simple node, what is junction, and what is principal node? Are you getting my point? Please tell me, are you getting my point? Simply, they are the basic definition. Now, moving forward to the KCL, I have just define each definition, each words which is provided in the definition. So, if it is a junction, and let us suppose there are more than two branches. Let us suppose more than two branches, and consider this is current I1, this one is current I2, and this one is current I3, and this one is current I4. Oh my God, all the currents are. This is current I4. Now, please be attentive at this point. This one is a node or junction. At this point, you have observed that the current I4 coming towards the junction, coming towards the node. I1 coming towards the node. So incoming current, incoming current, incoming current, incoming current means those current which are coming towards the junction. They are the I4 and I1. Outgoing current, outgoing current, outgoing current. That is, outgoing currents are, please, please, please reply. Outgoing currents are I2. I2 is outgoing away from the, moving away from the junction. I3 is moving away from the junction. So I2 and I3 are moving away from the junction. They are named as outgoing current. Incoming currents are I1 and I4. Outgoing currents are I2 and I3. Are you getting my point? Sir, simply we have determined two currents which are incoming current and outgoing current. Incoming current are those current which are moving towards the junction. Outgoing current are those current which are moving away from the junction. Note, note, note that, note that. What you have to note that incoming current should be incoming current should consider consider negative consider with negative mark, consider with negative mark and outgoing current current should be in positive mark. Now the summation of current, they have told that the summation of current at the junction point, it should be zero. The summation of current at the junction point. Summation of current means the summation of incoming current plus outgoing current. They have two currents, incoming and outgoing current. Both the summation of both these two currents should be equals to zero. Incoming currents are I1 and incoming current should be considered with the negative mark, that is minus I1 minus I4, and outgoing current are I2 and I3. Outgoing current should be taken is positive, that is plus how much? I2 plus I3, that is equals to 0. It means the summation of incoming current, you can rewrite this expression like this: I1 plus I4 is equals to I2 plus I3. It means all incoming current should be equals to outgoing current. Are you getting my point? Sir, simply you can say that the current coming at the junction point must be equals to the current leaving the junction point. That is the simple expression of KCL. Are you getting my point? The algebraic summation of current at the junction point is zero. That is, the total incoming current must be equals to total outgoing current. Is it clear? Is it clear? The total incoming current must be equals to outgoing current. Are you getting my point? The definition of each node, junction, current, incoming current, outgoing current. Mark my words, we will take incoming current always consider as a negative. Incoming current is always considered as a negative. Always consider as a negative. Incoming current always consider as a negative, whereas outgoing current always consider as a positive. Any doubt? Any doubt? No. Any doubt? Note. This law is based on this law is based on law of conservation of charge. Important, very, very important. This law is based on law of conservation of charge. It is based on law of conservation of charge. Important point. Last point doubt, sir. Which one? Which one? Incoming current should be equals to outgoing current. Is it? If there is a negative mark I1 and I4, just a simple transfer this I1 to this side, this one become positive, and I4 to this side, this one become positive, and this one I2 and I3 become positive one. positive. So you can say that I2 plus I3 is equals to I1 plus I4. Sir, leaving the positive or negative? It doesn't matter. It doesn't matter leaving the positive or negative. The point is, if this is the junction point and some currents are entering, coming towards the junction, and some currents are moving away from the junction. If the current moving away from the junction, if the current moving away from the junction, that is outgoing current. Away from the junction, that is outgoing current. Whatever it is positive or negative, doesn't matter. Just simple consider the junction point. If the current leaving this junction, then it is outgoing current. And if they are entering towards the junction, they are moving towards the junction, they are incoming current. Doesn't matter. Incoming current means I1 and I4. Always when you are going to apply the KCL, simply incoming current should be considered as a negative and outgoing current should be considered as a positive. But simply just mark my word. Mark my word. Khurshid Akhtar. Is it clear? Is it clear? Okay. Now, this law is based on the law of conservation of charge. Law of conservation of charge. Now, what I'm saying, just it is based on the law of conservation of charge. Just try this question. You are able to determine, you are able to apply the KCL. Just try this question. The question is, let us suppose there is an junction and current I1 is equals to 5 ampere, current I2 is equals to 10 ampere, current I3 is equals to 9 ampere. Determine the current I4. Determine the current I4. Option number A, 3 ampere. Option number A, 3 ampere. Option number B, 4 ampere. Option number C, 6 ampere. Option number D, 9 ampere. The next question. Please reply. Option number B, 4 ampere. 4 ampere. Okay. So this is 4 ampere. How can you say that, sir, this is 4 ampere? Sir, this one is your junction point. Junction point. Incoming current I3 and I1 are incoming current. Incoming current. So incoming current and outgoing current I2 and I4 are outgoing current. Are outgoing current. Outgoing current. So simply what you have to done, summation of incoming current I3, incoming is negative, I1 plus summation of current at the junction point, that must be equals to 0. So incoming current I1, just simply take incoming current I1, incoming current I3, outgoing current I2, outgoing current I4, that is equals to 0. Incoming minus का 5, out minus 9, outgoing I2 plus 10, I4 is equals to 0. 9, that is 1 ampere, and this is equals to I4. I4 is equals to 4 ampere. Simply, you have to apply the algebraic addition. Option number B is the correct option. Option number B is the correct option. Clear? Clear? Now the next question. Next question is, now the next question. Sir, do we need to write negative from incoming and positive from outgoing, or we can just evaluate the sum of incoming and outgoing current? We have to write. We have to write positive and negative, because then only law of conservation of charge is validate. We have to write we have to write negative and positive, negative and positive. That because this will balance the law of conservation of charge. This will balance the incoming current must be equals to outgoing current. Incoming current must be equals to outgoing current, and then only the summation of current at the junction point that will become equals to zero. So for this expression, for this summation of current that be equals to zero, we have to mark negative for incoming current and positive for outgoing current. Karanjit, clear? Any doubt? Okay. Now let us suppose there is a node which have branches like this. Let's say this one is I1 that is equals to 10 ampere. This one is I2 that is equals to 8 ampere. And this one is I3 that is equals to 8 ampere. Now this one is I5. Let's say this is minus 5 ampere. This one is I6, let's say 2 ampere. Determine I7. Determine I7. Determine I7. Determine I7. Quick, 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 quick. Be quick. 29. Anyone? Anyone? Any other? Other student? Okay. Okay. First of all, here I1 is incoming current. So I'm just going to apply the KCL. I'm just going to apply the KCL. Okay, 19. Okay. KCL states that the summation of current at the junction point that must be equals to 0. So summation of incoming current is minus 10. Okay. Now this one is outgoing. Outgoing is taken as plus. So plus of 8 ampere. Again, incoming is I3. I3 is taken as negative. This one is outgoing of minus 5 ampere. Minus 5 ampere. Now, another. This one is I7. I7 is outgoing of I7. And this one is incoming of minus 2 is equals to 0. So, you can cancel out this one and this one become 12. 10 or 2 is equals to minus 12. I think minus 5 is also minus 17. I think it become minus 17. Karanjit, it become minus 17. Is there any mistake while solving? 15 or 2, 17. I am getting 17 ampere. I am getting 17 ampere. Oh, I think you have done. No, 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 no. What you have told? 19 ampere. 19 ampere. 10, 8 get cancelled with the 8. Okay. And this one is 15. 15 to 17. Yes, this 17 is the right answer. Why it become 19? Why it become 19? I think you are confused with this minus word. Minus. Actually, this minus means the current is moving towards inside, that is 5 ampere. If there is a question, the current is denoted outward with the negative signs, it means the current is moving inside, moving towards the junction. Current is moving towards the junction. So maybe you have make it positive, and you have considered this one is this current is outward, and you have taken this minus 5 ampere in a positive manner. Am I right? Am I right? Am I right? Actually, the magnitude, you have to just simply place the value of magnitude what it is given. Just take simple. If current moving towards the junction, take negative. Moving away from the junction, take positive 8 ampere. Moving towards the junction, take 8 ampere minus of negative of 8 ampere. Moving away from the junction, you have to consider positive, but the given value is already negative. Then place this value of with the negative value. I7 outward, take positive of I1. I7. This is incoming current of 6 ampere. Take it is negative and solve this value. This will become the current of unknown value. Now, next point is next point is wait, wait. Now, next question is, let us suppose I'm asking a question. Let us suppose this one is your junction. This one is current I1. I1 is equals to 8 ampere. This one is current I2. I2 is equals to 6 ampere. And you have to determine I4. You have to determine I4 if you have to determine I4 if I3 is equals to 16 ampere. Options are given. Let's say 4 ampere. Option B minus 4 ampere. Option C minus 2 ampere. Option D plus 2 ampere. Be quick. Option D 2 ampere. Okay. Okay. You have done a mistake. Apply KCL. Just simply apply KCL. KCL state that the summation of current at the junction point that is equals to 0. Sir, this one is your junction point. Junction. Very good. Very good. Oh, very good. Very good. Now, simply, sorry. Simply, you have to apply KCL. KCL, incoming current is minus I1. Incoming current is minus I2. Outgoing current is my plus I3. Outgoing current is plus I4. बराबर कितना? 0 is equals to 0. Sir, simply I1, the magnitude of I1 is equals to 8 ampere. Magnitude of I2 is equals to 6 ampere. Magnitude of I3 is equals to 16 ampere. And the magnitude of I4 is equals to what? 0. Sir, this become minus 14 and plus 16 plus I4 is equals to 0. So I4 is equals to, let's say I4 is equals to, this will become plus 2 plus 2. This will become plus 2. So is equals to 0. So I4 is equals to minus of 2 ampere. This state that most of you are get confused. Sir, you have told that I4 is outgoing current and it is considered as positive, so it become positive. But the problem is The I4 should be in negative. Negative means the current should entered in this manner. Current should entered in this manner. So if 2 ampere of current get entered through this junction, then only law of conservation of charge satisfy. Option number C is the correct option. Option number C is the correct option. Are you getting my words? Getting my point? This current will actually become the incoming current, not the outgoing current. But they have asked the what is the outgoing current. Outgoing current will opposite to the incoming current with a negative sign. With a negative sign. Getting my words, Akhtar and Karanjit. Akhtar and Karanjit. Getting my words? Okay. Now, now, very good. Go try to solve next one. Now, we are moving to the second law of Kirchhoff, that is KVL, Kirchhoff voltage law. This is second Kirchhoff law. This is also known as second form of the second law of Kirchhoff. Kirchhoff. I think this is the correct spelling. Please check it. Maybe I am wrong. This is the Kirchhoff law. It states that it states that it states that the summation of KIRCHO, okay, single R, KIRCHO, okay. Thanks for the correction. Thanks for the correction. Okay, so it states that the summation of voltages in a closed loop is 0. Summation of voltages in a closed loop, that must be equals to 0. Closed loop, the summation of voltages in a closed loop, or better, I would like to define it more. The algebraic summation. It states that the algebraic summation of voltages in a closed loop must be equals to 0. Must be equals to 0. It means what? There are two words. First of all, the algebraic summation of voltages, not a word, sentence. The another is closed loop is equals to 0. First of all, we must know about the closed loop. We have to know about the closed loop. As we have discussed the junction, incoming and outgoing current, so simply we can discuss here, that is closed loop. Closed loop. Anyone can define the closed loop? Those loop that allow to flow the current become closed loop. Those loop that allow to flow the current become the closed loop. For example, let's say this is voltage and this one is resistor. This is a closed loop. This one is a closed loop. This one is voltage because current will allow to flow in this path. That is the closed loop. This is also known as closed loop. Sir, can we check the previous page problem once more? Yes, sure. Previous page problem or previous problem? That is this one on the same page. On the same page. My answer is coming 17. Okay, 17. Yes, it is 17. It is 17. Minus 17 or 17? Your answer is 17 or minus 17? 17. Yes, this one is right. Now, it states that the summation of voltage in a closed loop that must be equals to 0. Summation of voltage in a closed loop that must be equals to 0. It means summation of voltage in a closed loop that must be equals to 0. So hopefully, let us suppose this one is your closed loop. This one is your closed loop R1 and this one is R2. If there is any voltage, this one is also a closed loop. When there is any resistor in the circuit, then let us suppose this one is your current. So the resistor will allow to drop the voltage look like this. Where the current entering through the resistor, this terminal become positive. Mark my words, please, please, please be attentive at this point. When there is any resistor, if current entering through this resistor, then the terminal become positive. If the current entering through this terminal, then this terminal become positive and this terminal become negative. Are you getting my point? Always. In case of resistor, if current entering through any terminal, through the terminal polarity become positive. In a similar manner, if the current entering through this terminal become the positive manner. This terminal become the positive. So this is the simple relation. This is the closed loop. This is the closed loop. Now, how we are going to apply the KVL? How can we apply the KVL? How can we are going to apply the KVL? Simple. Let us suppose this is the positive terminal voltage and this one is a resistor. Please be attentive. Be attentive. This one is your closed loop. Let's say this one is resistor R1 and this one is resistor R2 and this one is current I. If the current entering with this terminal should be positive and this terminal should be negative. The current entering from this terminal should be positive and this terminal should be negative. Now, in a closed loop, this is the closed loop. Apply KVL. KVL states that the summation of voltage in a closed loop that must be equals to 0. Mark my words always in your whole life. That is, while having the KVL, just simply consider the polarity. If you are going to consider the first polarity, then you can write this. If you are going to consider the first polarity, then consider the first polarity of this this closed path. While moving in the closed path, I have considered the negative terminal, first polarity. Then I have to consider the first polarity. Then I have to consider the first polarity of each element, whatever it is. Each element I have to consider the first polarity. Now, this is minus of V plus I or R1 plus I into R2, that is equals to 0. This is the simple KVL. Now you can rewrite this I into R1 plus I into R2. This is basically the current entering through this terminal. Is it become source or sink? This voltage becomes source or sink? Current entering with the negative terminal. Yesterday I have told you that which element becomes source and which element becomes sink. If the current entering through the negative terminal, this becomes source or sink. This becomes source or sink. If the current entering through the negative terminal, then this becomes the source or sink. This becomes source or sink. Source. And in the similar manner, if the current entering with the positive terminal, this resistor becomes source or sink. This resistor becomes source or sink. Resistor becomes source or sink. Also, this resistor is also become a source or sink. Source or sink. Resistor becomes source or sink because the current entering with the positive terminal. If the current entering with the positive terminal, then it become if a current entering with the positive terminal, then it becomes source or sink. Please reply. Please reply. If a current entering with the positive terminal, the element is source or sink? Sink. Only one student will reply. Hmm. Now, here you can say that this become the rise of voltage. If we are going in this manner, negative to positive, then rise of voltage. From positive to negative, drop of voltage. From positive to negative, drop of voltage. Drop of voltage. So basically, we are saying that summation of rise of voltage, summation of rise of voltage, summation of a rise of voltage is equals to summation of drop of voltage, drop of voltage. Basically, what we have considered total summation of voltages in a closed loop that must be equals to zero. This law is based on note. This law is based on law of conservation of energy. Law of conservation of energy. This law is based on law of conservation of energy. Every time law of conservation of energy is conserved in this segment. In this law, it means KVL. KVL. Now, this is the simple topic. The question related to this topic are very, very simple. Let us suppose you have a 10 volt. Let's say the current I is flowing through this 2 ohm resistor, and the resistor R is given, and the voltage across this is 2 volt. Then you have to determine the voltage V. You have to determine the voltage V. Your options are 6 volt, option number B, minus of 6 volt, option number C, 2 volt, and option number D, minus of 2 volt. Minus of 2 volt. Please reply. Fast, quick. Very quick. Very quick. Such topics are very, very, very easy. What is written about 2 ohm? 8 volt. What is written about 2 ohm? That is 8 volt plus minus 8 volt. Minus 2 volt. I don't think it become minus 2 volt. Anyone? Anyone? Any other student? Any other student? Any other student? Okay. So while it is a closed path, sir, this one is positive and this one is negative. Sir, this one is closed path, closed loop. If closed loop, then the summation of voltage in a closed loop that must be equals to 0. Now you have to consider what? 6 volt. 6 volt. Hmm? How it becomes 6? How it becomes 6? It abolishes the law of conservation of energy. Akhtar is also saying 6 volt. Karanjit 2 volts. Very good. and Akhtar is saying 6 volt. Saina is also saying 6 volt. No, 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 no. No. I have told you that summation of voltage in a closed loop that must be equals to 0. What I am telling you, just simply consider this polarity. You have to start from this and consider this polarity. You have to consider this polarity, then simply write this minus of 10 volt. Now, moving in a closed loop, I am going towards this. Again, the first polarity is this one. The first polarity is this one. So I have to consider plus 8 volt. Now, moving further, if I am going to move this polarity, the first polarity of each element, that is equals to plus of V. And again, there is no such element that is equals to 0. Now, what you are going to say that? What you are going to say that this one is minus 2 volt plus V and this one is 0. V is equals to 2 volt only. V is equals to 2 volt only. Is that clear? Is that clear? Is that clear? Is that clear? Okay, no. The another question. Another question. Another question. No. Try to solve with having better precaution than previous question. Let us suppose I have different element. Let's say this one is X. Let's say this one is Y. And let's say this one is Z. This one is Z. And now a voltage source is applied. A voltage source is applied. Let's say the current I is entering from here. And I don't have any idea. But one thing, I have 10 volts, 100 volt source, and the voltage of this one is 20 volt, and the voltage of this one is 80 volt. 80 volt. You have to determine the voltage of Vz. You have to determine the voltage of Vz. Your options are option number A minus 30 volt, option number B plus 30 volt, option number C data insufficient, option number D cannot be determined, cannot be determined. Please be fast, be fast. Okay. I think I have to make one more option. I have to make one more option. Okay. That is 0 volt. No. Tell me. No. Again, tell me. Hmm. Zero. Okay. Very good. Option E. Very good. Now, very good. So this one is negative and this one is positive. So while considering, you have to take any element. So the first element is negative. So I have considered a negative of 100. Again, then positive of 20 volt. Again, how much? The positive of 80. You have to take positive of 80 volt. Again what? Positive of Vz, that is equals to 0. So 100 will get cancelled with this, that is Vz is equals to 0. Vz is equals to 0 is nothing but short circuit. Short circuited. It means this is simply replaced by a wire. This is simply replaced by a wire, that is short circuit. Okay. Let me ask the another tricky question. Another let me increase the difficulty level. How can we I'm going to increase this difficulty level. Okay. Let us suppose this is 100 volt and a resistor with the voltage drop of 20 volt and a voltage and a battery is connected with a 10 volt. Okay. Now the another battery which is get connected with this terminal, that is negative and positive of 100 volt. You have to determine the resistance, the voltage across this resistance R plus minus V. You have to determine the value of V. Your options are your options are 200 volt, option number B minus 170 volt, option number C plus 170 volt, option number D minus 200 volt. Okay. 170 volt. Very good. Karanjit. Anyone other? Any other student? Any other student? Any other student? One 170 is right. Very good. 170 is right. So basically, from anywhere you have take this one is not negative, this one is positive. Sir, I have take 100 volt. This one is positive of 20 volt. Again, this one is positive of 10 volt. Again, this one is negative terminal, negative of 100 volt. Again, this if the current entering, this one is positive of V is equals to 0. Now 100 or 100 is equals to 200 minus 30, that is voltage is equals to 170 volt. So hope you are very well known to this KVL and KCL. Our next topic is our next topic is please switch off your mic, please. If you want to ask anything, then you can ask. After asking, just please mute your mic. Google Pixel 7. Google Pixel 7. Google Pixel 7. Please, please, please mute your mic. Now, we have completed circuit element, Kirchhoff law. Now, we are moving towards the mesh and node analysis. Mesh and node analysis. After that, we are moving towards the network theorem. Do you want break? If you want a break, then we will take a break of 10 minutes. After that, we will start the next session. We can have the rest of 10 minutes. We can have the rest of 10 minutes. Okay, okay. Take a rest of 10 minutes. We will start after 10 minutes. So I'm not ending the session. Session will remain continue in mute mode. So we will start after 10 minutes. It is, I think, time is 5:18. 5:18. We will start at 5:30 p.m. 5:30. Right now it is 5:18 p.m. We will start at 5:30 p.m. जी। हेलो। 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 नारायण हरि अंकल जी। हेलो। इतना गंदा नेटवर्क हो गया है जियो का, क्या होता है ये।
नारायण रिंकल जी। हाँ, नेटवर्क बहुत गंदा हो गया जियो का। करते हैं आप इसको कंप्लेन कई लोग से करवाना पड़ेगा। कई लोगों से कंप्लेन करवाना पड़ेगा। पानी भर गया है। कंटिन्यू रहेगा तो कंटिन्यू
Okay, are you there? So we can start our next topic. Yes. Okay, 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 okay. We can start our next topic, that is we are moving towards the mesh analysis and the node analysis. Our next topic is mesh analysis. It will take at least 1.5 hours, minimum 1.5 hours it will take. So first of all, we are going to start with the mesh analysis. Mesh analysis. We are going to start with the mesh analysis. Now, what is difference between mesh and loop? Anyone? What is the basic difference between mesh and loop? I'm just asking, just for a general knowledge. What is basic difference between? What is difference between mesh and loop? What is difference between mesh and loop? Anyone? Anyone? Any idea? Any idea? Just just tell me. Just tell me. If you have any idea, just tell me. Sir, this one is loop and this one is mesh. Okay, let me define. Mesh is a loop. Mesh is a closed loop. Mesh is a closed loop which which doesn't which doesn't contain any inner loop. Any inner loop. Which does not contain any inner loop. For example, for example, let us suppose this is a mesh. This one is positive and this one is negative. Let's say this one is resistor and this one is a resistor and this one is also a resistor. The closed path. How many closed paths are there? First of all, sir, this one is your closed path. This one is your loop, loop 1, closed loop. And this one is also your closed loop, loop 2. There are two closed loops. There are two closed loops. Is there only two closed loop? No. Sir, there is another loop. There is another loop, that is L3. There is another loop, that is L3. Now, there are three closed loops, R1, R2, and R3, if these are the resistors. So, this closed loop L3 has two inner loop. L3 has two inner loop. L3 has two inner loop. Inner loop. Which one? L1 and L2. L1 and L2. L3 has two inner loop. Whereas L1 and L2. L1 and L2 does not have does not have any closed loop, any inner loop. Hence L1 and L2 is mess. L1 and L2 is mess. So mess is those closed loop which does not contain any inner loop. Are you getting my point? What is inner loop? So first of all, this is the question related to test your concept regarding to the mess. This one is resistor R1. This one is resistor R2. Now, if this one is resistor R3 and this one is resistor R4 and this is a resistor R5, how many mesh are there? How many mesh are there? Please determine how many mesh are there. How many mesh are there? How many mesh are there? How many mesh are there? Your options are option number 1, 2, option number B, 2 mesh, option number B, 3 mesh, option number 4, C, 4 mesh, option number D, 5 mesh. How many mesh are there? How many mesh are there? 3 mesh. Very good. So you can say that, sir, this one is loop, this one is also a closed loop, and this one is also a closed loop. This one is loop 1, loop 2, and loop 3. So hopefully there are 3 meshes. How many meshes are there? There are 3 meshes. Because meshes are those which does not have inner loop. Now, basically, what we are going to say, that is how procedure of mesh analysis. Procedure of mesh analysis. What is the basic procedure of mesh analysis? Basic procedure of mesh analysis. Of mesh analysis. Procedure of mesh analysis. The first step, what you have to do? The first step, identify the total number of mesh. Identify the total number of mesh. Second one is assign the mesh current. Assign the mesh current. While assigning mesh current, consider the same direction of current in each mesh. Now, third step, develop the KVL equation. Solve the variable or solve the equation. This is the simple procedure how to apply the mesh analysis. Simple procedure. Need not to worry about this description, sir, how we are going to apply. Now, how many meshes how can you identify that how many equations get developed in any network, any circuit? So equation of mesh, total equation of mesh is equals to b minus n minus 1. B minus n minus 1. Or equation of mesh, you can rewrite this b minus n plus 1. This is the total number of equation developed in any network if have B number of branches and n number of nodes. B number of branches and n number of nodes. Where B is equals to total number of branches. B is equals to total number of branches and n is equals to total number of nodes. Total number of nodes. And em is equals to equation of mesh. This is the equation of mesh. Simple. If I'm going to apply this procedure, then you are able to understand how this mesh analysis is going to apply. First of all, let us suppose there is a 10-volt source and a resistor of 5 ohm, and again a resistor of 5 ohm, and again a resistor of 10 ohm, and this one is 5 ohm is connected. While having mesh analysis, you have to take a current, identify the mesh. So there are two meshes, assign the current with the same direction, and it is also always take as a clockwise direction. This one is current I1, assign the current I2. Develop KVL for mesh 1. This is mesh 1. This is mesh 2. Develop, apply KVL for mesh 1. KVL for mesh 1. That is summation of voltage in a closed loop that must be equals to 0. So minus of 10, let's say the current will flowing through this I1. So sir, this polarity is positive, this one is negative. 5 I1. And in this branch, the current, while considering mesh 1, the current I1 is the highest, is always take as positive, and I2 will be negative. If this direction of current is considered in mesh 1, then this will taken as 5 times of I1 minus I2. Are you getting my point? Are you getting my point? For this branch, if mesh M1, mesh M1 is considered, mesh first is considered, then I1 minus I2 will be taken as a consideration of voltage drop across the 5 ohm resistor, that will taken as 0. Now you have to develop the expression I1, I2, 5, I2 is equals to 10. Now 10 I1 minus 5 I2 is equals to 10, or you can say that 2 I1 minus I2 is equals to 5. Expression number 1. Expression number 1. Are you getting? Are you getting how this mess get developed? How this mess get developed? Any issue? Any issue related to this concept? Any issue related to this concept? Any issue related to this concept? If you have any doubt related to this concept, then please ask me. Please raise your hand. I'm going to reply this one again. Okay. So again apply KVL in mesh second. Mesh second. That is summation of voltage in a closed loop that must be equals to 0. If the current I2 entering from there, so this one is positive, this one is negative. This one is positive and this one is negative. So last part, how it comes 5. By dividing the whole equation with the value of 5. Sorry. It become 2 now. Oh, sorry. It become 2. Okay, 5 2 tens. Thank you. 2. Now apply. That is 10 I2, and while considering the mesh 2, you have to take current I2 minus I1 in this branch. I2 minus I1 while considering mesh 2. The current in this branch, that is equals to I2 minus I1 into 5, that is equals to 0. That is 10 I2 plus 5 I2 minus 5 I1 is equals to 0. This will rewrite like it will 15 I2 minus 5 I1 is equals to 0. Here we can say that 3 I2 minus I1 is equals to 0. This is equation number second. This one is equation number first. You can say that I1 is equals to 3 times of I2. I1 is equals to 3 times of I2. This one is expression here. Now, you can replace this value to 3 times of I2 minus I2 is equals to 2. You can say that, sir, 6 times of I2, that is I2 is equals to 2. This will equals to 5 I2 is equals to 2. Then I2 is equals to 2 by 5 ampere. 2 by 5 ampere. Or I1 is equals to 3 into 2 by 5 ampere. That is 6 by 5 ampere. This is the simple mesh analysis. This is the mesh analysis. Simply you can say that this is the simple mesh analysis. Hope you are getting my point. Hope you are getting my point. Is there any doubt related to mesh analysis? 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 Please ask if there is any doubt related to mesh analysis. No. Okay. So if you have crystal clarity, then please solve this question. Question is, let's say, I have to ask one critical, or you can say that easy question. That is, let's say this one is 2 ohm resistance. This one is 2 volt. Let's say this one is 1 ohm resistance. Let's say this one is another 1 ohm resistance. 1 ohm resistance. Let's say this one is another 1 ohm resistance and again 1 ohm resistance. Okay. The current I you have to determine 1 ohm resistance, and there is a current source of 2 ampere. You have to determine the value of current I by using mesh analysis. By using mesh analysis, determine I. Okay, solve this. Solve this. Anyone? Anyone? May I? Are you still okay? Okay, 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 okay. Sure, sure, sure. No problem. No problem. Take your time. राहुल चाय पिला दो भाई यार. हाँ? चाय पिला दो मुझे यार, भूख लगी. चाय ऑनलाइन लोगे? दूध लेके आओ. मेरे पास कैश तो है नहीं. है क्या कैश? लो भाई. अरे मत लो. फिर कभी चाय पिला दे. और जितना था हम दे दिए. अख्तर, करणजीत. Actually, Karanjit, tell me how many mess are there? Tell me how many mess are there? I'm not going to solve right now, but tell me how many mess are there? Three. Okay. Okay. Let's say these are the three messes. This is mess I1. Let's say assigned with current I1. Let's say assigned with current I2. Always, always while considering the mess, each mess have the same direction of current same direction of current, and assigned with the different denotation of the current I1, I2, and I3. The trick of this question is in this mess 3, the I3 is known and the value is 2 ampere. No need to apply the no need to apply the KVL in this mess. Are you getting my point? Are you getting my point? No need to apply the KVL in mess 3 because I3 is known value. I3 is known value. You have to write the mess equation for mess 1 and mess 2. You have to write the mess equation for mess 1 and mess 2. Now, now, from this point, you can solve. Now, take your time. I will assign for 3 to 3 minutes. 3 minutes or more, enough. 3 minutes. Hmm. 3 ampere. Hmm. 6 and 3. I1, I2. Hmm. I1, I2, 3 and 6. Okay, let's check. Very good. Okay, so for mesh 1, apply KVL, Kirchhoff voltage law. So minus of 2 first, minus of 2 plus positive and negative of 2 ampere. Current is I1. 2 times of I1. Again, the current I1 is moving in this direction and I3 in this loop in this direction. So while considering the mesh 1, you have to consider I1 minus I3. I1 minus I3. So you are going to consider I1 minus I3. I3, the value itself. The value itself. Again, in this mesh plus I1. That is I1 minus I2. That is equals to 0. Now, you are going to consider this value I1 plus, I think this one is 1 ohm, sorry. This one is 1 ohm. This one is I1 minus I3. I3 itself 2 ampere. 2 ampere plus I1 minus I2. I2. That is equals to 0. Now, I1, 3 I1 and 4 I1. This is equals to 4 I1 minus I2. That is equals to 4. This one is expression number 1. This one is expression number 1. This one is expression number 1. How many of you are getting this expression? 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 Okay, need not to worry. Consider this is mesh number second. Mesh number second. Apply KVL. It means summation of voltage in a closed loop that must be equals to 0. Simply apply the KVL. While applying the KVL, the current entering from this terminal, that is 1 into I2 plus, while considering 1 into I2 minus how much? I1 plus 1 into I2 minus how much? I3. That is equals to 0. Consider I2 plus I2. This one is equals to I1 plus I2 minus I3. I3 is equals to 3 ampere. Sorry, 2 ampere. That is equals to 0. I2 and I2. 3 I2 minus I1 is equals to 2. This is expression number second. This is expression number second. Two expression, two unknowns. Are you able to eliminate this value? Are you able to eliminate this value? Easily you can eliminate. You can eliminate this by using the expression minus I1 plus 3I2 is equals to 2, and this one is 4I1 minus I2 is equals to 4. You can simply multiply with this factor. You can easily get minus 4I1 plus 12I2 is equals to 8. You can easily get minus 4I1 plus I2 is equals to minus 4. This one get cancelled by each other. That is equals to plus 11 I2 is equals to I think this one is plus 12. That is I2 is equals to 12 by 11 ampere. 12 by 11 ampere. I2 is equals to 12 by 11 ampere. Now you have to determine I1. I1 can be determined from here also. That is 2 minus. You can determine I1 from anywhere. 4I1 is equals to 4 plus I2. You can determine from here. 4 plus I2. I2 is equals to 12 by 11. That is 44 plus 12 upon 11. That is equals to, I think, 6 and 556 by 11 divided by 4. Divide by 4. So you can write from here. I1 is equals to 56 by 11 into 4. That is 4 ones are 4 and 4 fours are 16. That is 14 by 11 ampere. So you have to determine I2 only. That is I1 is equals to I2. That is equals to 12 by 11 ampere. Hope you are getting my point. Hope you are getting my point. Is there any doubt? Is there any doubt? Is there any doubt? Have you have you identified your error while solving this question? Did you find your error? Are you getting your error? Oh my God. Oh, sorry. I think I was muted. Okay. Okay. Sorry. Hmm. Okay. So I have simply just apply the KVL in mesh 1, that is minus 2, 2 times of I1, and this one is 1 ohm I1 minus I3. While considering mesh 1, I1 minus I3. While considering mesh 1, I1 minus I2. Simply, I have developed this expression, and in place of I3, I have just put the value of 2 ampere. I have got this value. This value. In mesh number 2, I have simply apply the KVL. While applying the KVL, I have simply take 1 times of I2, 1 times of I2 minus I1, and this I2 minus I3 in this expression. Just simply put the value of I3 in this expression. I3 is equals to 2 ampere in this expression. I have get this expression. While solving this expression 1 and 2, I have easily found that I2 is equals to 12 by 11 ampere. So this is I2. You can also find the value of I1 from this expression. You can easily find the value of from this expression. So important point is this, it is little bit lengthy, but the expression, the solution, you have to know how to apply the mesh analysis. So you have also attempt this question before mine. So have you find your error where you was wrong, what you have done wrong while attempting by yourself? Are you find your error? Are you able to find your error? Okay. Okay. Now, the next question. Next question is also related to the mesh analysis. Next question is also related to the mesh analysis. Next question is also related to the mesh analysis. And the question is very, very simple, but it isn't tricky, little bit tricky. It will look like very easy. It will look like very, very easy, but it will little tricky. And the expression is, your circuit is look like this. That is, this will be 2 ampere, and this one is the resistance of 1 ohm, and this one is resistance of voltage of 2 volt. Now you have to determine the value of current in this branch. You have to determine the value of current in this branch by using mesh analysis. By using mesh analysis, determine I. Try to attempt this question. Try to attempt this question. तो 7 बजे तक मैं करता हूँ 7:30 आपको कॉल करता हूँ। हाँ, अब निपटा दूँ इन लोग का, वरना I think I have to take, I have to provide a proper hint. You are not able to apply. First of all, tell me how many meshes are there? How many meshes are there? First of all, tell me how many meshes are there? How many meshes are there? 2. Okay, very good. So 2 meshes are there, I1, and this one is I2. Now what? If you are going to apply the KVL in mesh 1 or mesh 2, if you are going to apply the KVL in mesh 1 and mesh 2, you are not able to apply because the voltage across this current source is not determined by you. The voltage across this current source is not determined, not given, so you are not able to apply the KVL in mesh 1 or in mesh 2. In both meshes, we are not able to determine the value of voltage across this current source. Note, important point is this. Note, we are not able to able to apply KVL in mesh 1 and in mesh 2. Now what? How can we determine? For this question, for such type of question, if we are not able, such type of question, if there is any closed loop and a current source is present, then we have to develop the equation of supermesh. Develop the equation of supermesh. For developing the equation of supermesh, you have to take the outer loop. Outer loop should be the equation of supermesh. This is supermesh. This is supermesh. It means outer loop. Outer loop is considered as supermesh. Is considered as supermesh. Important point. So, equation of supermesh. Equation of supermesh is given by apply KVL in supermesh. In supermesh, how can we apply them? Now consider minus of 4 volt, minus 4 volt. Again, the current, let consider the current I1 in this branch, in this loop. While you are traveling from this, then you have to, you are in mesh 1, then consider I1, then this is 1 into I1. Now we are moving from here to here. Now we are in mesh 2, and mesh 2 have current I2, that is plus I2. Again, the first polarity is 2 volt, plus of 2, that is equals to 0. Now we are going to develop the expression I1 plus I2 is equals to 2. That is expression number 1. Two unknowns, one expression. How can we solve this? Now here the current I1 is moving downward and I2 is moving upward. Now from this expression we can say that the net current I2 is moving upward. Then you can say that from this expression I2 minus I1 is equals to 2 ampere. This is the expression number second. Now simply add both expression, that is 2 times of I2 is equals to 4, that is I2 is equals to 2 ampere. I2 is equals to 2 ampere. Or you can say that, sir, I1 is equals to 2 minus I2. So I1 is equals to 2 minus I2 is equals to 2. That is I1 is equals to 0 ampere. Easily you can say that, sir, this is I is equals to I2 is equals to 2 ampere. Are you getting my point? This is the expression of super mesh. This is known as super mesh expression. Super mesh expression. Karanjit, Akhtar, Ko, are you getting? Are you getting the expression of super mesh? Very good. 2 ampere, 2 ampere, 2 ampere. Very good. Now, now, while having all this, we have to apply the equation. How many? Maximum equation of mesh. The simple. Those have the same current. If they are asking, if they are asking how many, if they are asking how many equations can be developed, if they are asking how many equations can be developed, let us suppose in this circuit, if they are asking how many equations can be developed, equation of mesh can be developed in this network. How many equation of mesh can be developed in this network? Let's say this one is R1, this one is R2, this one is R3, this one is R4, and this one is R5. R5. Now you have to determine how many mesh equations can be developed. So equation of mesh is equals to B minus N minus 1. How many nodes are there? Sir, this one is node 1, this one is node 2, this one is node 3, and this one is node 4. There are 4 nodes. So N is equals to 4. How many branches are there? If we are going to say that this one is branch 1, this one is branch 2, this one is branch 3, and this one is branch 4, and this one is branch 5, and this one is branch 6. 6 branches are there. B is equals to 6. Now equation of mesh is equals to 6 minus 4 minus 1, that is equals to equation of mesh 6 minus 3. You have to develop 3 equations to solve this expression by mesh analysis. To solve this expression by mesh analysis. Are you getting my point? Sir, minimum 3 equations are required. Maximum 3 equations are required. How many? Maximum 3 equations are required. Is it clear? Is it clear? Is it clear? So definition of branch. Definition of branch. Definition of branch. Those, how can you determine the branch? Branch, current branch can be the combination of two or more than two elements which have same current, they are known as branch. How can you determine the node? The common point which the common point where more than two elements are connected, and current get divided at that point. They are nodes. Part of a network which connect the various point of network to the another. Yes, that is also the branch. Now we are moving towards, this is mesh analysis. We are moving towards node analysis. What is node analysis? Need not to worry. Very easy concept, just like a mesh analysis. We are moving towards node analysis. This is the second node analysis. Node analysis. Node analysis, and one thing very important, maybe in your exams, your exam is related to AE examination, maybe they have asked, but in JE examination generally they didn't ask anything related to this concept. Mesh analysis is valid is valid only for planar network. Planar network. I will tell you what is planar and what is non-planar. Node analysis. So procedure of node analysis. Procedure of node analysis. Procedure of node analysis. What are the procedure of node analysis? First, identify the total number of nodes. Identify the total number of nodes. Total number of node. Okay. Again, mark the reference node. Reference node. Mark the reference node with 0 volt. 0 volt. Always mark a reference which have maximum number of branches are connected. Always make a reference node to that node which have maximum number of branches are connected. Third, develop the KCL at each node. KCL at each node. And the fourth one, solve by solving KCL. By solving KCL. By solving KCL, identify the voltages or determine the voltage. Determine the voltage. How many equations of node can be developed? That is n minus 1, where En is equals to equation of node. N is equals to total number of node in network. Okay. Before going to the node analysis, I just want to develop a concept related to the node. Let us suppose this is potential, this is resistance, and let's say this is potential VA and this is potential VB. And now let's say this across this 5 volt. Okay, 5 volt. Okay, let's say this is the voltage difference. Now let us suppose this have 1 ohm resistance. So the current will flow always in the resistor where the positive terminal are given. The current is right VA minus VB upon R. So the value of current is VA minus VB, that is equals to 5 volt, upon M1, that is equals to 5 ampere of current will flow through this branch. Are you getting my point? If you are getting my point, then tell me, if the value of resistance is 1 ohm and this is 7 volt, this terminal is 7 volt and this terminal is 2 volt, the value of current I. Please reply the value of current I. Please reply the value of current I. 5 ampere. Very good. 5 ampere. Okay. Yes, it is 5 ampere. Sorry, it is 5 ampere. That is equals to 7 minus 2 upon 1. That is equals to 5 ampere. Okay. Now, if I'm going to ask you, let's say this is 2 ohm resistance. This one is 10 volt and this one is minus 5 volt. The value of current through this branch, the value of current through this branch, the value of current I through this branch, 7.5 ampere. Very good, Karanjit. Very good. And you can say that, sir, I is equals to 10 minus of 5 upon me 2. That is equals to 15 by 2. That is equals to 7.5 ampere. Very good, very good, very good. Now, I just want to develop another concept related to the determining of current. Let us suppose if you have a resistance and a battery, if you have a resistance and a battery like this, if it has 20 volt resistance of 2 ohm, and this one is positive and negative, a resistance of a battery of 6 volt, and this have the polarity of 0 volt, the value of current I in this direction. The value of current I in this direction. Seven ampere. Okay. Let's say, sir, simply I is equals to the voltage 20 minus 6 minus 0 upon me 2. That is equals to 14 divided by 2. That is equals to 7 ampere. Hopefully you are getting my point. Now, the another concept is, let's say this is 5 ohm and this one is plus minus 10 volt and this one is 6 volt. 6. Let's say this one is minus 10 volt. Sorry, wait. Let me make it little bit difficult. Let's say this one is 10 volt. This one is minus 2 volt and this one is 100 volt. You have to determine the value of current and the value of current. You have to determine the voltage and value of current. 17.6. Okay. So I is equals to 100 plus 10 minus, actually you have to take the polarity. The polarity is 100 plus, the polarity is minus of minus 10, the polarity is minus of minus 2 upon 5. That is I is equals to 100 plus 10 plus 2. 112 divided by 5. 112 divided by 5. 5 twos are 10. 5 twos are 10. 5 is which is so. 5 twos are 10. 5 twos are 10 and 5 twos are 10, 5 fours. That is I is equals to 22.4 ampere. I think this one is the right answer. Please check if there are any calculation mistake. If there are any calculation mistake or you are not, if you are not getting the concept, then please reply. Please ask me. If you are not getting the concept, then please ask me. Now we are going to solve the question that will develop your concept related to the mesh analysis. Let us suppose, sir, put wrong polarity. I put wrong polarity. Okay. Just you have to identify one thing. Always current will always flow from higher potential to lower potential. Always mark. Always current that is higher potential. This one is lower potential. Always current will flow from higher potential to lower potential. Higher potential to lower potential. That is, mark my word. That is, current will always flow from higher potential to lower potential. Okay. Now let us consider a resistance of value 1 ohm and voltage of value 4 volt, 4 volt, and another resistance of 1 ohm and another voltage plus minus of 2 volt, again 10 ohm, 10 ohm, again 2 ampere of current, 2 ampere of current. You have to determine the value of current flowing through this branch I. You have to determine the value of current I flowing through this branch by using using node analysis. Need not to worry. First question, I have to solve this one, and after that you have to solve the another related to the same concept related to the node analysis. So our procedure for solving the question is identify the total number of node. Identify the total number of node. I'm just going to identify the total number of node. Identify the total number of node. Node number 1. This is the same node because the same conductor is connected and the same current will flow through this branch. Then this will become the same node. This one is the another node and this one is the same node because the same conductor is connected through all the branches. Now there are two nodes. Then equation of node required to solve this network, that is n minus 1, that is 2 minus 1. Only one equation is enough to solve this network. That is, one equation is enough to solve this network. Okay, sir. Now, if one equation is enough to solve this network, then our concept is, first of all, mark the reference node with the zero polarity. Always mark the reference node to those node which have the highest number of branch connected through the node. So highest number of branches, if you are going to talk about the highest number of branches, then this is branch 1, this one is branch 2, and this one is branch 3. All the 3 branches are connected through this node, and the same 3 branches are connected through this node. Then you are not able to say that this have the highest number. Both have the same number of branches connected. Now in this case, if the same number of branches are connected, always consider the lowest node as a reference node. So I have considered the lowest one as the reference node. It is just because it will uh, allow us to solve the equation in very frequent manner. That's why. If it is 0 volt, let's mark a voltage polarity, that is V, and assign a current I1 always while applying the KCL. I'm just saying, apply KCL at node V. Apply KCL at node V. That is summation of current at the junction point that must be equals to 0. While applying the KCL, just simply take the current away from the junction, that is I1, I2 and I3. I have considered the current I1, I2 and I3 in each branch which is away from the junction, that is outgoing current from this junction point. Then you can say that the summation of current I1 plus I2 plus I3 that is equals to 0. Now what? Can you tell me the current value of current I1? Yes, sir. I have an idea. The value of current I1 is written by V minus 4 upon me 1. So, sir, we can simply written as V minus 4 upon 1 plus V minus 2 upon 1. So, simply we can write that V minus 2 upon 1. Again, sir, the current I2 current will flow like this. The current I2 is just opposite to this one. That is I2 minus of 2. You can write in this way. Now, 2V minus 6 is equals to 2. You can write this expression is equals to 8. That is V is equals to 4 volt. V is equals to, you can write like 4 volt. Now you have to determine the value of current I. I is nothing but the current I2. That is, I is written like V minus 2 upon me 1. V minus 2 upon me 1. That is, the value of V is equals to 4 minus 2 upon 1. And that is equals to 2 ampere. Are you getting my point? Are you getting my point? How easily you are able to determine the value of current I? Are you getting my point? Is there any doubt related to this concept? Is there any doubt related to this concept? Not only I1, you can easily determine the value of current I. Not only I2, you can easily determine the value of current I1. V minus 4 upon 1. That is 4 minus 4 is equals to 0. Is equals to 0 ampere. You can determine each current in each branch. Each current in each branch. Are you getting my point? Is there any doubt related to the node analysis? Is there any doubt related to the node analysis? Is there any doubt related to the node analysis? Is there any doubt related to the node analysis? Please ask, please ask. Otherwise, we will move further towards the next question. And very funky question. Very funky question. Should we move? Should we move? Should we move? Are you getting my voice? Is that everything clear? Everything fine? I think you people get exhausted. I think you people get exhausted. Okay, take a deep breath. Take a deep breath. After that, we will start the next question. Take a deep breath. No, sir, continue. Okay, 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 okay. Okay. Now, your next question is very much interesting question. Now, the question saying that this is the voltage of 10 volt. This one is voltage of 10 volt. And this one is resistance of 1 ohm. This one is resistance of 1 ohm. 1 ohm. And again, this one is resistance of 1 ohm. And again, this one is resistance of 1 ohm. You have to determine the value of current I. And this one is also the value of resistance of 1 ohm. By using mesh analysis, by using node analysis, find I. You have to determine the value of current I. Okay, let's start. Your time starts now. You have 5 minutes. 5 minutes? Yeah.
You have 5 minutes. Yeah, I think 5 minutes is more than enough. So you have 3 minutes to solve this question. बताओ, अब बोलो। यही रात भारी, यही रात अंतिम, रात भारी, यही रात अंतिम। Okay, 5 ampere. Sir, fine. Let's complete the nodal analysis today. Okay. Now, okay, I think 5 ampere. 5 ampere. Is everyone getting the same answer? Everyone getting the same answer? Okay, let's start the node analysis. By having the node analysis, this one is branch 1, this one is branch 2, this one is branch 3, this one is branch 4, this one is branch 5, this one is branch 6. Sir, I have 6 branches. Sir, B is equals to 6. Sir, this one is node N1. Sir, this one is node N2. This one is node N3. And this one is node N4. So total number of node are 4. Now equation of node is equals to node analysis is equals to n minus 1. That is equals to 6 minus 1. You have to write the 5 equation. Huh? 6 node? Oh, sorry, 4 nodes. Sorry, 4 nodes. You have to develop the 4 minus 1, that is 3 equations are required. Now, at most you have to 3 equations are required. At most you have to 3 equations are required. But when we are going to consider this one is a reference branch, this one is a reference branch with 0 volt. If this is the reference branch, then if we are going to from negative to positive, then it is the rise of voltage or drop of voltage. If we are going to rise a negative to positive terminal, if we are going to negative to positive terminal, then it will become a rise of voltage. Sir, if this voltage is 0 volt, then rise of voltage, this node voltage has known voltage that is equals to 10 volt. Need not to apply the node analysis at this node. How many unknown nodes are there? This node is unknown, V1 volts. This node is unknown with V2 volt. Two nodes are unknown. Need not to apply the node analysis at this node. Only two node are unknown. Two node are unknown. So we have to develop the equation for node, how much? Node 3 and node 4. Only two node equations are required. Two node equations are required. So simply what you have to do? You have to do simply flow the current I1, current I2, current I3 through this node. So simply apply apply KCL at node 3. At node 3, you have take the current I1, outgoing current, that is positive, I2 as an outgoing current, that is positive, I3 as an outgoing current, that is positive. Now the voltage of this node is assigned with V1 minus 10 upon में how much? 1 ohm of resistance. Again V1 minus 0, the current through I2, V1 minus 0 upon में 1, that is V1 minus 0 upon में 1, plus current through I3, that is V1 minus V2, V1 minus V2 upon 1, that is equals to 0. Simply you can say that 3V1 minus V2 is equals to 0. This is expression number 1. This is expression number 1. You can say that, sir, this is first equation. Now apply the KCL. Apply the KCL at node second. At node number 2. Sorry, 4. At node number 4. Now if we are going to consider the node number 4, then we have considered the three currents I3. Let's say this one is I4, this one is I5, and this one is I6. Simply the summation of current in a at the junction point, that must be equals to 0, and all the currents are moving away from the junction, that is outgoing current, that is plus I4 plus I5 plus I6 is equals to 0. Is equals to 0. Then you can say that, sir, V2 minus how much? V2 minus V1 upon me 1 plus V2 minus 0 upon me 1 plus V2 minus 10 upon me 1, that is equals to 0. V2, that is 3V2 minus V1 is equals to 10. That is expression number 2. This is expression number 2. Now you have to determine the value of V1 and V2. You have to determine the value of V1 and V2. What you are going to say that? Sir, we have two expressions. Which one? 3V1 minus V2 is equals to 0. 3V1 minus V2 is equals to 0. Sorry. 3V2 minus V1 is equals to 10. 3V2 minus V1 is equals to 10. Now, if I'm going to say that from here V2 is equals to 3 times of V1, you can simply put 3 times of V1 minus V1 is equals to 10. Then you can say that 10 times of 339 or 1, sorry, 8 V1 is equals to 10. 8 V1 is equals to 10. Then V1 is equals to 10. V1 is equals to 10. You have to determine the value of V2. V2 is equals to 3 times of V1, that is 30 volt. 30 volt is V2. Now what we are going to tell you, I have to determine the current I. I is nothing but I5. 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 I5 is equals to V2 minus 0 upon, just say V2 minus 0 upon 1. Upon 1. The value of V2 is equals to 30 upon 1, that is equals to 30 ampere. I think it is 30 ampere. I think it is 30 ampere. I am getting 30 ampere. How much you are getting? 5 ampere. There is a huge difference. There is a huge difference. I am getting 30 ampere. How much you people are getting? Is there everything? Calculation is right now. V1 minus 10 upon 1, V1 minus 0 upon 1, V1 minus V2 upon 1. Okay, V1, 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 3V1 minus V2, and this one is, oh my god, we have missed the value 10. Okay, okay, okay. This is 10. Okay. Now I4 V2 minus V1 upon 1, V2 minus 0 upon 1, V2 minus 10 upon 1. So here, okay, I think there is a calculation mistake. It will look like 10. Oh my god. The whole concept, the whole calculation should be deleted. Now, that is 3V1. 3V1 minus V2 is equals to 10. 3V2 minus V1 is equals to 10. 3V2 minus V1 is equals to 10. Now, what I am saying that just multiply with 1, just multiply with minus 1, and just multiply with minus 1. Okay, minus 3 times of V1, minus 3 times of V1 plus V2 minus of 10, minus of 10 plus V1 plus V1, sorry, you have to multiply this with 3. You have to multiply this with 3. You have to multiply this with 3. 3. That is minus 3 V1 plus V2 is equals to minus 10. Now, plus 3 times of V1 and plus 9 plus 9 V2 is equals to 30. Okay, just add this, that is 10 V2 is equals to 20, V2 is equals to 10. V2 is equals to 20 divided by 10. 20 divided by 10, that is equals to 2 volt. Is it right? Please check. Please check, please check, please check. Please check it. Is it right? Please check. If I am wrong, just please make the correction. Please make the correction. Okay. If it is correct, then I have to determine the current I. I is equals to I5. That is V2 minus 0 upon 1. That is 2 minus 1 is equals to 2 ampere. V2 minus 0 upon 1. That is equals to 2 ampere. This will be the value of current I. Hopefully, you are getting the proper analysis of node analysis. Node analysis. One more question. One more question related to the node analysis. Try to solve this. Let's say, try to solve this question. Let us suppose this one is a current source of 2 ampere, and this one is the value of resistance. This one is the value of resistance of 1 ohm. Let's say a voltage source of 1 volt is placed between these two nodes. Okay, let's say this is also 1 ohm and another is also 1 ohm, and this one is plus minus 2 volt. Now you have to determine the you have to determine the value of current flowing through this branch I. You have to determine the value of current flowing through this branch I by using node analysis. By using node analysis. Node analysis. By using node analysis, you have to determine the value of current I through this branch. Okay, this is a special case when a voltage source is placed between the two nodes, then node analysis is quite difficult, and it is considered as the case of supernode. It is considered as a case of supernode. It is considered as a case of supernode. It is a case of supernode. Supernode. Consider the case of supernode. In this case, let's say this is the reference node and you have to determine unknown voltage V1 and this one is unknown voltage V2. So this node is considered as a supernode. These two nodes are considered as a supernode. Supernode. While solving this equation, let's consider these two nodes as a single node. Consider the two nodes as a single node or single node. And while considering the node, let's say that is current I1, that is current I2, and this one is current I3, and this one is current I4. Simply apply KCL at supernode. Apply KCL at supernode. Now you have to write the expression, that is current I1 plus current I2 plus current I3 plus current I4, that is equals to 0. I1 is nothing but plus of 2 ampere. I2 is nothing but V1 minus 0 upon may 1. I3 is nothing but V2 minus 0 upon may 1. I4 is nothing but V2 minus 2 upon may 1, that is equals to 0. You can simply say that 2 and 2, 2 volt. This is equals to V1 plus 2 V1 plus 2 times of V2, and this one get cancelled with each other, that is equals to equation number 1. This one is expression number 1. You can say that, sir, this one is expression number 1. This is expression number 1. Now the another voltage, how we are going to develop the another voltage? For this development, for the another voltage, because there are two variables and one equation, we are not able to determine the unknown voltage V1 and V2. So for developing of second voltage, we are using the node that is supernode. We are using the supernode, and in this supernode there is a battery which have the polarity, which have the marked polarity, and marked polarities are, there is a marked polarity, this is negative terminal, that means it is lower potential, and this one is positive terminal, it means it is higher potential. So always if we are going to write the expression VAB, that is equals to potential at VA minus VB, potential at VA minus VB, and that is nothing but VAB is equals to higher potential, voltage at higher potential minus voltage at lower potential, voltage at higher potential minus voltage at lower potential. You can say that VAB is equals to how much? The difference between these two polarity, that is equals to 1 volt. The difference between these two polarity, it means VA minus VB is equals to 1 volt. This is expression number second, yani equation number second. This will help in providing the solution of these two expressions, solving the solution of these two expression. And this one VA is V1 and VB is V2 is equals to 1. That is expression number second. You can solve this equation with this equation V2 is equals to 0 by subtracting. If you are going to subtract this, 3V is equals to 1, that is V2 is equals to 1 by minus 1 by 3. What we have to determine? We have to determine V1. V1 is equals to 1 plus V2. That is V1 is equals to 1 plus minus of 1 by 3. That is equals to 2 by 3 volts. Now we have to determine the current I. I is equals to V1 minus 0 upon 1. That is equals to 2 by 3 ampere. This is the equation of, this is the current through this branch, 2 by 3 ampere. This is all about the node analysis. If you have any doubt related to any concept, then you can ask, and I will going to discuss the syllabus. I think, Pankaj sir, are you there? If you have any doubt, then please ask me. If you have any doubt, then please ask me. Now, what we have done in today's session, we have done Kirchhoff law, node analysis, mesh analysis. Kirchhoff law, node analysis, mesh analysis. Sir, how come the second equation is okay. Wait. So we have done this portion completed. This portion is completed. So from tomorrow onwards, our target is network theorem and its application. Network theorem and its application. Or I'm trying to solve this natural and force response. Trying to solve this concept also. Natural, transient, and force response and steady state response. Hopefully 4 to 5 hours class will be taken from tomorrow onwards. So basically, we will get complete within 3 days, 3 to 4 days. So this chapter will get completed if we are having 4 hours class daily. So I think 4 hours today, and yesterday we have taken 2 hours, 6 hours. Most probably 10 hours class are present for this. Total 16 hours class will be there for the electrical circuit. Okay. How we are developing the expression number second. Basically, there is a potential difference between these two nodes, V1 and V2. The potential difference. Higher potential have voltage V1. So simply higher potential minus lower potential, and the potential difference of 1 volt. That is equals to 1 volt. So this is simply V1 minus V2 is equals to 1 volt. Are you getting my point? Are you getting my point? Okay, just wait for a minute. Just wait for a minute. हो गया सर? हाँ, क्या करना है? एंड कर दूं? नहीं, बहुत हो गया। Okay, we will meet tomorrow. I will send the PDF of this class in your WhatsApp group. So try to write this question, and I will also send the question related to this concept like KVL, KCL, as well as node and mesh analysis. Sir, after the end of the topic, please say, yes. I will share the topic related to practice this question. So you can able to practice and able to solve, and while having the practice, you can increase your speed while solving the question. Okay. Sir, please share some. Yes, sure, 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 sure. Don't worry, don't worry, don't worry. Don't worry, need not to worry about this. I will share the question. Okay. Thank you, everyone. Thank you, class. We will meet soon in the next session. Be ready. Hopefully, we have 5 hours class of at least 4 hours. I think from tomorrow onwards, 1 hour to 4 hours, 1 p.m. to 4 p.m. 1 p.m. to 4 p.m. I think this will 3 hours class.